Kinetic energy. When we talk about kinetic energy, we're dealing with energy in motion. And it's the result of work done to get the object up to its velocity or to stop it. The units that we use for kinetic energy are joules, which are the same units that we use for potential energy. When we look at our equation for kinetic energy, it's a little bit more complicated than a potential energy equation. Our kinetic energy equation is Ke equals 0.5 times m times v squared. Ke in the equation stands for kinetic energy, and the units are joules. M in the equation stands for mass, and the units are in kilograms. And V stands for velocity, and the units are in meters per second. Now, when we do these kinds of problems, order of operations are important. So the steps in going through this particular calculation are as follows. The first thing we want to do is we want to square the velocity. That means we're taking the velocity and multiplying it by itself. The second step then is to take that number and multiply it by the mass. And then finally, we're going to take the number and multiply it by 0.5. So let's look at a couple of questions. What is the kinetic energy of a 4 kilogram cart traveling at 6 meters per second? So we should notice that this is a kinetic energy problem, so we start with our kinetic energy equation. So kinetic energy equals 0.5 times m times v squared. Then we're going to plug in our variables. So for m, we'll plug in 4 kilograms. For v, we'll plug in 6 meters per second. Now we go back to the steps in the calculation, and our first step is going to be to square our velocity. So we're going to take 6 squared, or 6 times 6, and that's going to give us 36. We're also squaring the units, so we get meters squared over seconds squared. The second step in our calculation is going to be to take that number and multiply it by its mass. So we're going to take 36 and multiply it by 4. So now we have kinetic energy equals 0.5 times 144 kilogram meter squared per second squared. Our last step is going to be to multiply by 0.5. So we're going to get kinetic energy equals 72. And the units are kilogram meter squared per second squared, but we're going to shorthand that as a joule. So when we look back at the order of operations for this problem, the first step is to square the velocity, then we multiply that by the mass, then we multiply it by 0.5 to get our answer. So now let's look at a second problem. What is the kinetic energy of a 10 kilogram cart traveling at 14 meters per second? Again, we recognize it as a kinetic energy problem, so we start with our equation. Kinetic energy equals 0.5 times m times v squared. We plug in our values, so we'll plug in 10 kilograms for m and 14 meters per second for v. And then we go through our order of operations. So we'll square our v first, so 14 times 14. That'll give us 196 meters squared per second squared. We'll take that number and multiply it by the mass, or 10 grams. So that'll give us 1960 kilogram meter squared per second squared. And then finally, we'll multiply that by 0.5, and the kinetic energy will equal 980 joules. So again, when we look at this problem, we recognize it as a kinetic energy problem when we write our equation. We should actually have our variables written there as well. We'll plug in 10 kilograms for mass, 14 meters per second for velocity. Square the velocity, multiply it by the mass, multiply it by 0.5, and that gives us our answer.